All right, let's talk about the invisible rules that stop our digital world from falling into chaos. I'm talking about SQL constraints and keys. They're kind of the unsung heroes that keep all our data clean and reliable. So let's pull back the curtain and really see how they work. Okay, to get our heads around this, let's use a super simple analogy. Just picture a college, right? It's a huge, complex place, but it runs on some basic rules. Like every single student has a unique roll number, and every student has to belong to a specific department. That simple idea, that's exactly how we keep our databases organized. And that roll number you see on a student ID card, well, that's a perfect real-world example of what we call a unique identifier. There's just no way two students can have the roll number 101. It points to one person and one person only. And honestly, without that guarantee, all the data would just become a huge, unreliable mess.
Okay, so we've got the college analogy down. Let's start connecting that to the real technical terms. We've been talking a lot about rules, right? Well, in the world of SQL, these rules have a name. They're called constraints.
And a constraint is, well, pretty much exactly what it sounds like. It's a rule that you set on a column in your database table. Its whole job is to enforce the integrity of your data, to make absolutely sure everything is accurate and reliable. You can think of it as the database's built-in defense system, stopping mistakes before they can even happen. So, this really breaks down the three main players we're going to be focusing on. First up, you've got the primary key. That's our main unique identifier, like the student roll number. It has to be unique, and it can never be empty or null. Then there's the unique constraint. It also makes sure there are no duplicates, like for a department name. And finally, the foreign key. This is the big one for connections. It's the glue that links one table to another, building those all-important relationships. All right, that's enough theory for now. Let's actually see this stuff in action. We're going to get our hands dirty and build our very first table. We'll start nice and simple with a list of departments for our college database. So here it is, the actual SQL code. We're running a create table command for departments, and I want you to pay close attention to the keywords here. See how primary key is being assigned to the ID column, and how unique is assigned to depth name? This is us setting the rules of the game right from the very beginning. And that little piece of code, it creates this. Yeah, it's an empty table for now, but look closer. It has a very specific structure. You can see the ID column is now officially our primary key, and the DPT_name column is marked as unique. Our foundation is now officially set. So what do these constraints actually do for us? Well, the primary key on that ID column guarantees that every single department will get its own unique number, no repeats, no empty values. And that unique constraint on depth_name, that's what stops us from, say, accidentally creating two different physics departments. See, they're simple rules, but they have really powerful results. Okay, awesome. We have our departments table. But, a list of departments isn't very useful all by itself. Now we need to add our employees, and this is the crucial part, link them to the correct department. This is where everything starts to connect. And this line of code is where the real magic happens. We're using alter table to modify our employees table. First, we add a new column called depth ID. Then, and this is key, we declare it a foreign key that references the ID column back in our departments table. This creates what's called referential integrity. It basically makes it impossible to have orphan records, like an employee who's assigned to a department that doesn't even exist. And here's what that looks like. Our employees table now has this new column, depth ID, and its only job is to hold the ID of the department that employee belongs to. This little column, depth ID, has now become the bridge that connects our two separate sets of data. So let's bring this all the way back to our college analogy. By creating that foreign key, we've basically laid down the law. Just like every student has to be enrolled in a real existing department, every employee on our database must be linked to a valid department that we know for a fact exists in our departments table. No exceptions. Okay, so we've gone to all this trouble to set up these rules, but you might be wondering, why does this matter so much? Well, it all boils down to one incredibly important concept: protecting the integrity of your data. And believe me, these rules have a massive impact in the real world. Think about your bank. Constraints are what make sure every single account is tied to a valid customer. Or when you're shopping online, they guarantee you can't place an order for a product that doesn't even exist. This isn't just theory. It is the absolute bedrock of any reliable system. But that raises a good question, right? We've talked about how great these rules are, but just how strong are they? I mean, what happens if we deliberately try to break them? What if we try to feed the database some bad data? Well, let's find out. Okay, here's the scenario. Let's imagine we already have a computer science department in our table. Now we're going to try to insert a second department with the exact same name. We are intentionally trying to violate that unique constraint we set up way back at the beginning. And what happens? Rejected. The database immediately throws an error. It just stops us dead in our tracks. And look, it even tells us exactly what rule we broke. The unique constraint on the dept name column. The system literally protected itself from our own mistake. I really love thinking about it this way. Constraints aren't just a bunch of boring, restrictive rules. They're more like guardians. They are standing watch over your data, 24/7, actively protecting it from getting messy, inconsistent, or just plain wrong. So let's do a quick recap of the big ideas here. It all starts with the primary key. That's what gives every single row its own unique identity. Then we use the foreign key to build those bridges, creating relationships between our tables. And watching over the whole thing, that's the job of constraints, the set of rules that guarantee our data stays clean and totally reliable. And really, this is the main takeaway. When you use keys and constraints the right way, you're doing more than just storing data. You're elevating your database. It stops being just a bunch of disconnected tables and transforms into a smart, reliable system, something you can actually count on. So, the next time you're using an app or browsing a website, just take a second to remember these silent guardians working behind the scenes, keeping all that data in perfect order. Now, coming up next, we're going to build on this foundation and dive into SQL transactions. That's where we'll learn how to safely manage a bunch of database operations all at once. It's going to be good. I'll see you there.